How are we doing there, guys? So today we are going to do a lab activity called Discovering Density. Okay, we're going to take a look at a couple of different materials, and we're going to learn how to find the density of those materials. And every different material has its own unique density, right? So in our lab today, I have two different metals. One of them may or may not be gold, and one of them may or may not be silver. And what we're going to do is we're going to find their densities, and we're going to compare those to the densities of gold and silver and some other metals. And we're going to try to determine whether or not these materials are gold or silver or something else. So let's take a look at our lab, and let's get to it. All right, we are going to be finding the volume of our metal using a method called water displacement. And what we're going to do is we're going to take a graduated cylinder, we're going to put our little bit of water in there, and then we'll put our metal in there. And the volume of the water level will go up a little bit. And the amount that it goes up is the volume of our metal that we put in there. And so in our laboratory directions, it tells us this equation here. It says the volume of our solid is equal to the final volume minus the initial volume. So that final volume that it went up to minus that initial volume that it started at. And before we get started on the lab, there's some pre-lab questions. And the first one asks us to solve these problems here. They tell us the initial volume, they tell us the final volume, and they want us to calculate the volume of the solid, which is very easy. All we have to do is subtract those two numbers. We just have to be a little bit careful because the equation says take the final volume minus the initial, and the data that it gives us the initial volume first. So we don't want to subtract this way, we want to subtract this way. We want to take the final volume minus the initial volume. So the first one there, it tells us the final volume is 19.3 milliliters. The initial volume is 7.6 milliliters. And if we subtract those, the volume of the solid should be 11.7 milliliters. For the second one here, the final volume, 20.1, minus the initial volume, 8.0, gives us 12.1 milliliters. And then the third one there, the final volume, 18.4, minus the initial volume, 6.2, gives us 12.2 milliliters. All right, let's see, on question number 2, it tells us that the numbers they gave us in question 1 were based on some kind of metal cylinder. And what it wants us to do on question 2 is it wants us to use what we know about geometry to find the volume of that metal cylinder. Now, the formula to find the volume of a cylinder is pi times the radius times the height. And it gives us the radius is 1.05 centimeters, and the height is 3.32 centimeters, and of course we know pi is about 3.14. So let's put those numbers in there and let's see what the volume of the cylinder is using this method. So pi times the radius times the height gives me about 10.9. And then, of course, that would be cubic centimeters. All right. And it also asks us to calculate the percent error. So here we have, I left this up here, the numbers that we calculated from question number 1. These would be the measured value of the volume. And here is the accepted value of the volume. And let's figure out the percent error for each one of these 3 measurements here. So what we'll do to find the percent error is we'll take that measured volume minus the accepted number divided by the accepted number times 100. So for the first one, we have 11.7 minus 10.9 divided by 10.9 times 100. And there we get about 7%. We have about 7% error on that measurement. Okay, For the second one, we have 12.1 minus 10.9 divided by 10.9 times 100, which is about 11%. About 11% error. And then for the last one here, we have 12.2 minus 10.9 divided by 10.9 times 100. And there we get about 12% error on that one. So there is the second pre-lab question. Let's see, the last pre-lab question, it gives us 3 pictures of a target, and it asks us which one is accurate, which one is precise. Okay, so the first one, you can see all the dots are close to each other. When all your measurements are close to each other, we say that it's precise. So A would be the precise one. If you see in B, all of the dots are close to the target. If you're close to the target, if you're close to the right or accepted answer, we say that's accurate. So B would be the accurate one. And then C, you see they're kind of just spread out. They're not close to each other, and they're not close to the target. That one is neither accurate nor precise. So for that third pre-lab question, A is precise, B is accurate, and C is neither. All right, now let's get into the lab. I have here 4 little samples of a material that may or may not be gold, right? And what we're going to do is we are going to first measure their mass on the scale, and then we're going to measure their volume by water displacement. We're going to put a little bit of water in there, then we'll put the metal in there, and we'll see how much the volume goes up. And that'll be the volume of the sample of metal there. And I'm going to record them on my little paper here, and I'm going to make for you a fancy little data chart to go up at the corner of the screen. And then we will divide the mass divided by the volume to find the density. And actually this lab is going to ask us to make a graph of it. So we'll make a graph of mass versus volume, and we'll find the slope of the line on the graph, which will be the density. Okay, so now let's get to this. First, I'm going to open the lid of my scale here. I'm going to turn it on. Okay, I'm going to put a weighing dish on there, and I'm going to zero the scale. And then we'll put our first sample in here. Here's sample number 1. And for sample number 1, it weighs 13.52 grams. Okay. Now put this on here. Zero the scale. We'll go with sample number 2 here. Sample number 2, 15.46 grams. Put this on here, zero the scale. Sample number 3, 19.80 grams. And then sample number 4, 11.05 grams. Now, I'm not mixing up my samples. I have them in order here. So when I do the volume, I know which volume corresponds to which mass. Okay, we're done with the scale. I'm going to put that away. All right, now I'm going to put a little bit of water in my graduated cylinder, and then we'll put sample 1 in there, and we'll see how much the volume goes up. All right. Now, you probably can't see it. I put about 10 milliliters of water in this graduated cylinder, and I'm going to put sample number 1 in there, and we'll see how much it goes up. So right now, starting off, its initial volume is 10, and its final volume, let me read this here, is about 11.5. So it went up from 10 to 11.5. 11.5 minus 10 is about 1.5 milliliters. So the volume for sample 1 1.5 milliliters. Okay, let me reset this here and we'll do sample 2. Okay, I again have an initial volume of about 10 milliliters in here, and now we've got sample number 2. We'll put sample number 2 in and see how much the water level goes. Okay, so it started at 10, and now it is right about 11.5 as well. So it's gone up about 1.5 milliliters again. Okay, let me reset. We'll do sample 3. All right, once again, I'm starting out with about 10 milliliters of water, and I'm going to put sample 3 in here. And now it's gone up to about 12, 12, yeah. So it's gone up to about 12. So it's gone from 10 to 12. 12 minus 10 is about 2 milliliters. All right, reset, we'll do sample 4. All right, last one here, sample 4. I'm again starting with about 10 milliliters of water in there. Put in sample 4. And now we've gone up to a little less than 11.5. I'd say about 11.25. So we're going to go with 11.25 on that one, which means it's gone up 1.25. All right, so now we've taken all of our data. We've got the mass and the volume for each one of our 4 samples. Now the directions want us to make a graph. So let's go ahead and use graphical analysis to make a graph. All right, now we've taken some data about the mass and the volume of our metals. Let's analyze our data. Now the lab handout has some instructions for making a graph and analyzing the graph. But let's make it a little bit easier and let us use a computer program to make and analyze the graph. So I'm going to use a program called Graphical Analysis, made by a company called Vernier, Vernier's Graphical Analysis. When I open up the program, I need to choose a manual entry, and then it's going to give me a graph and a data table. On my x-axis, I am going to put the volume of my metals measured in milliliters, and on the y-axis, I am going to put the mass measured in grams. Okay, and you can see I get those on the axes of my graphs, and I'm going to enter my data that I collected, and you'll note that I put in the 0.00 because it makes sense that if I had 0 grams of my metal, it would have a volume of 0 milliliters. And you'll notice as I put the numbers in, points appear on my graph. Okay, now you can see that my points there, they line up fairly straight. There's 2 of them that are kind of right next to each other, but otherwise they line up pretty straight. So I am going to go into this menu here and choose a apply curve fit, and since they look pretty straight, like a straight line, I am going to choose a linear curve fit. Okay, now I get this box with some information about my line, and as you might know, M stands for the slope of the line. And you can see M in the box right there tells me the slope of my line. It says 9.82, and that should be the density of my metal, 9.82 grams per milliliter, or grams per cubic centimeter. Let's take a look at some different metals and see which one has a density close to that. All right, finally, let's take a look at the post-lab questions, and let's answer those, and let's figure out what our metal is. Was it gold or not? Okay, the first post-lab question, it says, does it make sense that any trend or pattern in the mass and volume data should include 0, 0 as a point? Explain your reasoning. Yeah, and I explained earlier that it would make sense to include 0, 0 as a point, because if the mass of my material was 0, I would assume it have a volume of 0, right? If there's none there, both its mass and its volume are going to be 0, right? Number 2, what kind of trend or pattern is obvious from the plotted graph and mass of the mass and volume data? Well, it's linear. It's a straight line, right? Is there a consistent relationship between mass and volume? Yeah, there's a very consistent relationship between them. Number 3, based on your answers to questions number 1 and 2, draw a best fit line through the data points, which we did in graphical analysis. And then it gives some instructions for the best way to do that, which we did. Number 4, calculate the slope, which we did in the program. It came out to 9.83, if I recall correctly. Let's see, number 5, are there any data points that seem out of place in the set? Yeah, we had 2 volumes that were very close to the same, and the reason that happened was because the graduated cylinder is only marked to every half milliliter, so it's hard to measure closer than that. So it looked like 2 different masses had the same volume, but in reality, we just couldn't measure more closely. Let's see, number 6, compare the calculated slope with that of another student. You can ask another student what they got. Number 7, use the table there to determine what kind of metal we had. Well, we had 9.8 something was our slope. And if you take a look at those numbers there, gold is not very close to 9.8 something, right? In fact, 9.8 something is closer to silver or copper. Our metal we had was actually brass. Maybe our slope is a little high because we couldn't measure the volume a little bit more carefully. Maybe if we could have done that, we would have gotten closer to the density of brass, but it was brass. It was not gold. If you had the silver sample, then it was not actually silver. It was actually zinc. Let's see, assuming that the identification of your metal is valid, use the equation they want us to find the percent error. Okay, so to find the percent error, we'll take what we measured minus the correct answer for brass was 8.5 divided by that times 100. Let me get my calculator here and we'll figure out what is our percent error. Okay, so I got about 15%. And maybe we could do better than 15%, but that's what we got here. And then number 9, optional. Density is calculated by dividing the mass and the volume, and then we could use that equation to find the density for each one of our data points. All right. So there are our post-lab questions.